All right, something huge is happening right at the heart of the AI revolution. And no, it's not a new model or some flashy new app. It's about the silicon, the actual chips. We're going to dive into this because OpenAI is making a massive power play that could seriously shake up the entire industry. $10 billion. Just let that number sink in for a second. That's not a company valuation. It's not a 5-year budget. Nope. That is reportedly the size of a single order OpenAI is placing for its own custom AI hardware. It's an absolutely jaw-dropping figure, and it signals a huge change in how the game is played. You see, this $10 billion bet isn't just about buying new toys. It's a declaration of independence. It's the price OpenAI seems willing to pay to get out from under the current supply chain and really take control of its own destiny in this AI arms race.
So, what is this all about? Well, it's official. OpenAI is partnering with the semiconductor giant Broadcom to create a brand new proprietary AI chip. And this isn't some far-off dream. They're aiming to launch it starting next year. This is a full-scale move to build the very hardware that will power the future of AI.
But to really get why OpenAI is making such a monumental investment, you first have to understand the market they're so desperate to escape. For years now, the entire AI world has been living inside this kind of gilded cage, and it was built by one company. And yeah, that gilded cage is pretty much owned and operated by Nvidia. The company has a near monopoly on the AI chip market. We're talking 80 to 90% of all data center accelerators. Now, if you're a company like OpenAI, whose models are incredibly power-hungry, this isn't just a dependency, it's a critical vulnerability. And that vulnerability, it comes with a very steep price tag. A single top-of-the-line Nvidia H100 GPU can cost you over $40,000. Now imagine you need tens or even hundreds of thousands of those to train your next-gen model. The costs just become astronomical. That is the financial pressure that's forcing everyone to look for another way. The stakes here are just enormous. And look, it's not just us saying it. As Richard Neva from Forbes points out, this move by OpenAI and others doing similar things isn't just a defensive play. It's a direct challenge to the status quo, and it could seriously threaten the very companies that have benefited the most from this whole AI explosion. But what's really fascinating here is that OpenAI's strategy, as huge as it is, isn't happening in a vacuum. Not at all. It's actually part of a much bigger pattern we're seeing across the entire tech industry, a pattern of independence. Just look at this list. It's a who's who of big tech. Google's got its TPU, Amazon has Trainium, Meta's got its own accelerator, and so does Microsoft. They have all come to the exact same conclusion. If you want to compete at the very top of the AI game, you can't just keep renting your tools. You need to own the factory. Now, there's a name for this strategy. It's called vertical integration. Here's an easy way to think about it. Imagine a world-class bakery. To guarantee the quality and cost of their bread, they decide to stop buying flour from a single supplier and just start growing their own wheat. That is exactly what OpenAI and all these other companies are doing, but with silicon. Okay, so we totally get the why. It's about control, it's about cost. So now let's get into the what. What do we actually know about this new chip that OpenAI and Broadcom are cooking up? Okay, what we're looking at is basically a semiconductor dream team. You've got OpenAI's vision, Broadcom's design genius, and TSMC's legendary manufacturing muscle. The goal? Super simple. Create a chip for their own internal use, cut costs, and finally crush that Nvidia dependency. And their ambition is staggering. They want to double their entire compute power in just 5 months. Oh, and they've got a veteran from Google's own chip team leading the charge. No big deal. Okay, let's get a tiny bit technical, but stick with me because this is actually pretty cool. The chip is expected to use a design called a systolic array. Now, in simple terms, think of it like a perfectly organized assembly line, but for math. Instead of one big, powerful processor doing all the work, it's a grid of smaller, identical processors, and the data just pulses through them in a super efficient rhythm. It's an architecture that is tailor-made for the kind of math that AI is built on. And check out this timeline. It is incredibly aggressive. They're finalizing the design in 2025, and mass production is set to kick off just about a year after that. By early 2027, these new chips will be fully plugged into OpenAI's systems. You know, in the world of silicon design and manufacturing, that is moving at absolute light speed. So, a $10 billion deal moving at this crazy pace, it's bound to make some waves, right? So what does this power play mean for the rest of the market? What are the ripple effects going to be? This move just fundamentally changes the game for OpenAI. I mean, look at the comparison. Instead of paying sky-high volatile prices, they get lower costs over the long run. Instead of being dependent, they get full control. They're swapping out general-purpose hardware for silicon that's literally custom-built for their own AI models. At their scale, this isn't just a nice-to-have. It is a strategic necessity.
And, well, you don't have to be a Wall Street genius to guess what happened next. The financial world reacted to this news immediately and decisively.
The market's reaction tells the whole story. As soon as the partnership was announced, Broadcom's stock shot up a massive 16%. Meanwhile, Nvidia's took a dip of over 4%. Now, this wasn't some catastrophe for Nvidia, but the signal was crystal clear. Investors see this whole in-house trend as a very real, long-term threat to that single supplier dominance. Which, of course, brings us to the final big question. Is OpenAI's $10 billion gamble the tipping point? Is this what finally breaks up the AI hardware market for good? Or is building your own chip just the new, incredibly expensive price of admission for anyone who wants to seriously compete in the AI arms race? Only time is going to tell, but one thing is for sure, the game has definitely changed.